Traveling on a straight road and braking, its velocity is measured here. Plot the data. Okay, so I'll do that over here. And so our time is 0, 0, 0.3, 0.6, 0.9, 1.2, 1.5, and 1.8. At 0, it was at 100, so I'll make that 100. Then 88, which is probably somewhere about there, and then 74, and 59, and 40, and 19, and 0. So something like that. Okay? Estimate the total distance traveled by the car using its brake using a middle Riemann sum 3 intervals. So from 0 to 1.8, which is 1.8, 1.8 minus 0, B minus A would be 1.8, divided by 3 is 0.6, which would be the width of my intervals. So 0.6, this would be one interval, 0.6 would be to there, and then 0.6 more would be to there. So I'm going to go to the middle, and unfortunately they give me the numbers right between this one, this interval, and this interval. I want to use the middle height, so I'm going to have for my middle using 3 subintervals, I'm going to have a width of 0.6. The height of the first one will be 88, because I want to do right in the middle, which is 0.3. Then right in the middle of this one, which would be 0.9, and that's 59. And then the middle of this one is 1.5, and the height is 19. So the height is 88, the height is 59, and the height is 19. So work that out, and that would be the answer to that one. Estimate the total distance traveled from 0 to 1.8 by doing left 6 and right 6. Well, if I do 6, each one would be, left 6 would be left side on it, 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 and left side on it, left side on it, got it off there, left side on it, left side on it, left side on it, got off on there. So those would be the left sides on it. So this is, of this first one, this would be the left side. Second one, that's the left side. Third one, that's the left side. Fourth, fifth, and sixth. So I'd use those numbers. Each one of those will be times 0.3. So I'm going to have, for the left 6, it's going to be 0.3 times 100 plus 88 plus 74 plus 59 plus 40 plus 19. For the right 6, it's going to be 0.3. I'm going to leave out the 100. I'm going to have the 88 plus 74 plus 59 plus 40 plus 19 plus 0. There's the right 6. The right 6 would be from this down, this down, this down, this down, this down, and that one. Okay? You can work out those two. And if I do the average of the left and right by half, that's actually trapezoidal 6. So they're having you do the trapezoidal. And you get the answer for this one, the answer for this one, add them up, divide by 2, and you got this. And the trapezoidal would look like this. That area. And then connect those dots in that area. That trapezoid, and that trapezoid. Okay? Assuming that the velocity is always decreasing in there, what is the maximum possible distance? Well, if it was going and then all of a sudden braked, and going and all of a sudden braked, going and some braked, going and some braked. So the max would be this one that's overestimate, which is the left one. So L6 would be the max, whatever you got for that answer. Okay, and 7. The rate of pollution that escapes from a scrubbing plant, it depends on how dirty the filters are and how other technologies become less effective. So the pollution that is escaping, the tons per week increases. The area under the curve would be how much tonnage actually escaped into whatever it's going into, rivers, streams, land, whatever. So they want us to do M4 from 0 to 4. That's a nice deal because then each one is a 1 wide. That makes it simpler. And M4, we would have to calculate the height at a half. So the M4 would be width of 1 times the height at 1/2, which looks like about 1.2, my estimate, plus at 1.5, which is 0.7. My bad. 0.7 plus 1.01 plus, sorry, move this up here for you so you can see what I'm doing. At 2.5, it looks like it's about 1.7. And then here it looks like it's up about 2.9. Those are my estimates. So that would be midpoint 4. 0.7, 1.8, 3.5, 5, 6.4 tons of pollution. What is the meaning? That's how many tons that would be discharged. If it was this, then we could get these values, use this formula to calculate L5. Well, if the width is that we're looking at from 0 to 4 weeks, that's 4 minus 0 over 5, which makes each 4/5 or 0.8. And if I'm doing, what they say, do left, so the left side to 0.8, then the left side to 1.6, left side to 2.4, left side to 3.2, and left side to 4. So, to do the left 5, I'll do it over here. Left 5 would be 0.8 for the height, or the width of each one of these. And the heights I would have to do, I'll call this R of, I got to put in 0 plus R of 0.8 plus R of 1.6 plus R of 2.4 plus R of 3.2. That would be doing the left. 1, 2, 3, 4, 5. Left 5. Okay? And it says, so I'd have to work that out. And I'm going to do that on my calculator. A little more practice here for us. I'm going to go to here, type in the equation, clear that one, 0.5 e to the 0.5x. There's the equation. I'm going to go now to stat, edit. I'm going to put where I want to evaluate at, which I'm going to clear this list, come down and put in 0, enter 0.8, 1.6, 2.4, and 3.2. And I'm going to come over here and I'm going to clear that list and put in vars y variable function y1 of list 1. That'll be the easy way to put those in. So it did all the calculations. And then we'll find the sum of that by quitting and going second stat math sum of list 2, second 2, close parenthesis, and I get the sum to be that, and each one was 0.8 wide, so I have to take it times 0.8. That worked out this, and that turns out to be 5.196 tons of pollution. Okay? Determine the upper bound for the total amount of pollution that can escape from the plant pictured in the 4-week period that is accurate to almost at most 1 ton of pollution. Error of at most 1 ton. Well, we did the left 5. We could do the right 5. Let's see what the right 5 works out to be. So what would be different is if I'm doing the right 5, I go to stat, edit, I'm going to get rid of the 0, and I'm going to put in the 4.0. Go back here and clear the list and do vars, y1 of parenthesis, list 1, close parenthesis. There's the new values. Second quit. Get the sum of that list. Second stat, math, sum of second 2, list 2. I get 9.68 times the width of the interval, which is 0.8. I get 7.75. Okay, so the most is going to be somewhere between here and the error. If I just go in the middle of this, the error is going to be, that'll be close to the actual value. And so if I find the average of these two, 5.196 plus 7.752, looking back here, divided by 2, I get an average of 6.474. Which would be a trapezoidal method. And you can see that that would be really close to the equation. And if the error is at most 1 ton, I probably would say, well, 7.4 is 1 ton more than that. It probably would not be more than that, because this is going to be really close, and a ton more than that would be this much, and so that could probably be my max area. That's a reasonable answer. Now, the actual answer for this curve would be the antiderivative of this, and the antiderivative of this, since e to the 0.5 t's derivative would be e to the 0.5 t times the chain rule would say times 0.5 gives us that. So this is the antiderivative. And if we want to find the actual area under this curve, if this is a good representation, would be e to the 0.5 times the end 4 minus e to the 0.5 times the beginning, which was 0. So I get e to the 2 minus e to the 0, which is e squared minus 1. I get 6.389, and if I'm trying to do within a ton, that would be 7.4, was still approximately right for the most off by a ton max. Okay?